All right, I'm now on the next page, starting with problem 3. Looks like we're still working with Jeffrey. It says, Jeffrey wants to make one planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so it is not taller than 3 feet. Explain how you know. All right, so he's building a planter that's going to be from the ground to just below his window. We know that the window is 3 feet off the ground. We also know that he wants the planter to hold 36 cubic feet of soil, which means that is the volume. So we're trying to think of dimensions that could get us 36 cubic feet of soil and a height of 3 feet, okay? So volume equals length times width times height. We have 2 of these things already. We have the volume, which is 36 feet cubed. We do not have the length, we do not have the width, we do have the height because he tells us it's got to be 3 feet off the ground. It could be less than that, but I'm just going to write 3 feet for now. Okay, so I need to find out 2 numbers that can be multiplied by 3 to get to 36. So what I'm going to do here is divide 36 divided by 3 and see what number I come up with. You could do this off to the side, but I know 3 goes into 3 once, 3 goes into 6 twice. So 36 divided by 3 is 12. So I know to get to 36 that I can multiply 3 times 12, that equals 36. Well, this is my height. I need more than one number, so I'm going to replace this 12 with 2 other numbers. So 2 numbers that multiply together to get to 12. We can do a couple things. I'll do 4 and 3. Okay, it doesn't matter which is the height or which is the volume. Or which is the width. So now I'm going to replace 4 and 3 with the length and the width. So 36 feet cubed equals, let's do 4 feet by 3 feet by 3 feet. So just to check, we have a height of 3 feet. We knew that the volume was 36 feet cubed. We can multiply these 3 numbers together to get to the volume that he wanted. We did not go over a height of 3 feet. So looks like this is pretty good. So our explanation, it says explain how you know. So since he wants to build So when I say the base of the planter should be 12 feet squared, I'm talking about going back to the previous lessons. If you think about, we knew that the height would be 3 feet. This would be a base, 12 feet squared. We thought of 2 numbers, 4 and 3, that would multiply to get to that. So I chose 4 feet as length, 3 feet as width. All right, let's move on to the next one. After all of this gardening work, Jeffrey decides he needs a new shed to replace the old one. His current shed is a rectangular prism that measures 6 feet long by 5 feet wide by 8 feet high. He realizes he needs a shed with 48 cubic feet of storage. Will he achieve his goal if he doubles his dimension? Why or why not? Okay, so as of now, his current shed, the volume equals 6 feet times 5 feet times 8 feet. And I got this from here, they've told us, right? This is all equal to 240 feet cubed. So I want you to try out on your own right now. Pause the video and see if he doubles each of these. Will he achieve his goal of 480 cubic feet of storage? So pause me now. All right, welcome back. So now we're gonna do shed dimensions doubled. So we need to double each of these numbers. 6 doubled is 12. 5 doubled is 10. 8 doubled is 16. So we are going to multiply these numbers to see what the volume is. I want you to pause now and work out that multiplication. All right, when we multiply these together, we get 1,920 feet cubed. So when we double the dimensions, it does not give us a volume of 480 cubic feet. So he cannot double it. And the reason he thought he could double it is because 240 is half of 480. But doubling this isn't the same as doubling each of these. You get obviously a much higher number. So no, he cannot double all of the dimensions. Let's move on to B. If he wants to keep the height the same, what could the other dimensions be for him to get the volume he wants? Okay, we're keeping the height the same. So shed, remember he wants a volume of 480 cubic feet. He wants to keep the height the same. The height we already have been given is 8 feet. So we don't know the length, we don't know the width. We know 8 as the height. So what can we do to these other numbers for him to get the volume that he wants? Well, we can decide what we want to change. Do we want to try changing the length, the width? What do we need to do? We knew that these original 3 numbers equal 240. So now I'm thinking, all right, what can I get to what can I change here to get me to 480? So let's try the doubling thing. I'm gonna start by doubling the length. So remember the original length was 6 feet. I'm gonna try doubling 6 feet and keeping the width the same, height the same, and seeing what we get, okay? So on your own now, I want you to multiply 12 feet. Remember we've doubled this, times 5 feet, kept it the same, times 8 feet. Pause the video now and see what you get. Okay, so it looks like when we did double the length, we were able to get 480 feet cubed. It says what other dimensions could we use to get him the volume he wants. So we've already figured out this one. Let's now figure out if we can double the width and keep the other 2 the same and see how that changes the volume. So remember our goal is 480 feet cubed. We are now going to keep the length the same. Remember, I'm going back to the original problem, 6 feet by 5 feet by 8 feet. So I'm keeping the length, and he also wanted to keep the height the same. So we are going to change the middle number, the width. I'm going to double it to 10 feet. All right, work this out and see if it gets you to 480 feet cubed. All right, after your multiplication, you should have found out that it actually does. So he was wrong in this first part. He only needed to double one of the dimensions. Remember, we doubled the 6 for the length, and here we doubled the width. So these are the 2 other dimensions that could get him the volume that he wants. All right, if he uses the dimensions in part B, what could be the area of the new shed's floor? Okay, so they're talking about the floor of a shed. Let's use 12 feet by 5 feet by 8 feet. All right, so the length is 12. Width is 5, height is 8. Width. All right, again, not a good drawer, but I'm trying my best. Okay, this is 5 feet. The floor of the shed is down here, right? We need to picture what that looks like. So if this was a see-through shed, let's say I can see through the shed. Obviously I can't, but we are pretending. This part down here is the floor. They want to find what the area of the floor is. So you're going back to 4th grade right now. You're thinking, all right, how do I find area? To find the area of the floor, I would multiply these 2 numbers together. Remember, area equals length times width. Here, our length would be 12, our width would be 5. Which means the area would be 60 feet squared. Remember, squared because it is area. And that's all.